Okay, so far we've looked at storing individual pieces of information in variables and then manipulating those individual variables using operators and functions. Um, Most of the things that you'll want to represent in your programs, though, are more complex than that. They're objects. They combine qualities such as an energy level, abilities like firing weapons in a spacecraft. And it makes no sense to talk about the individual qualities and abilities in isolation from one another. What you need to be able to do most of the time is combine those together into an object. For example, a person has arms, legs, eyes, a nose, ears. They have the ability to speak, to listen, to manipulate objects, to walk, to move from one location to another. They have the each person has individual qualities, such as their own energy level, their own intelligence, their own ability to speak. Um, that the qualities, intelligence, character, personality, um, abilities, the ability to walk, the ability to speak, the ability to see, to hear. Okay, and to try to express that in a programming language requires a discussion of objects. And most modern programming languages allow you to work with software objects, which are usually just referred to as objects, that combine the data and the functions. A data element of an object is called a data member, and then a function of that object is called a member function. Okay, let's think about an alien spacecraft. It might be of a new type called spacecraft, defined by the game programmer, and it might have a data member for its energy level and a member function to fire its weapons. Okay, the energy level might be stored in a data member called energy. That might be represented as an integer or as a float. Its ability to fire weapons would be a new function called fire weapons. Every object of that same type has the same basic structure, so each object will have the same set of data members and member functions. Um, what those are set to may be different. Okay, one alien spaceship of the object type spacecraft might have an energy level of 100. Another one might only have an energy level of 50. Even if they do have the same energy level, you can manipulate that energy level on each one individually. If you change one, it doesn't change the other. Okay. Your textbook shows a block diagram of this object. The object spacecraft has the data member of energy, which is an integer, and a member function of fire weapons, which is a function. Okay, so we talked briefly about strings, and a string is an object. It is an object type called string, and it has data members, which would be whatever information you store in the string, and member functions that we'll look at. Functions such as the length of the string. It can actually count how many characters are in it. In order to see what kind of functions and data members that string object has, we're going to work on a program called the string tester program. It uses a string object equal to game over with 3 exclamation marks. It'll tell you the length, the index or the position number of each character, and whether or not certain substrings are found within that particular string object. And then we'll go through and we'll erase parts of the string object, change parts, and eventually erase the entire string object. So let's go ahead and get started on our string object, or string tester program. I've got my new text document, and I'm going to save that. As string_tester.cpp, and I can go ahead and start my program. Name of my program is string tester, and this demonstrates string objects. I include IOString as per normal. I'm also going to include another library file called string. This is what actually allows us to work with strings. I'm going to give a directive that we're using the std namespace, and then go ahead and open up my main function. Okay, in order to create our string object, we're going to generate 3 different strings to begin with. The first one is going to be called word1, and that is equal to the word game. We have another one called string word2. Now this is another way that you can declare a string variable. Rather than using the exclamation mark, we're going to put the string object that we want to set the variable to between a pair of parentheses. So over in parentheses. This has the exact same effect as using the equal sign. However, this particular format leads us to what we can do here with our third string object. We have the number 3, a comma, and then in single quotation marks, an exclamation mark. Okay, what this will translate to is this exclamation mark 3 times. So this string will be 3 times an exclamation mark, which would be exclamation mark, exclamation mark, exclamation mark. Now, we're going to put these 3 objects together in another string object. We have a string called phrase, and we're going to set that equal to word1 plus, which in this case is not being used as an arithmetic operator, but as concatenation, putting multiple things together. An empty set of quotation marks with a space. This will give us the space between our words. And we concatenate in word 2 and word 3. Now, so we will see what this does. We will see out the phrase is phrase, and then 2 new lines. Okay, now we're going to look at some of the member functions. Actually, in this case, it's a data member of our string object. The phrase has phrase.size. Oh, you know what? This is a function, which you can tell because it has the parentheses after the end. Okay. The size member function is a function of the string object, and it tells us how many characters are included in our string. It returns an unsigned integer, and the value of that unsigned integer will be the size of the string, its number of characters. Okay. Now it's important to realize that these member functions and data members exist for all instances of our object. Okay. Every time we declare a string variable, word 1, word 2, word 3, phrase, These are all instances of the string object. Okay, going back to my code, we're going to say that this has phrase.size, characters in it. Now, we want to figure out what the character is at position 0. Okay, in this case, what we're doing is we're looking at the index of that object. This looks at what the very first element is in that string object, what the very first character is. We start with 0. Every time we're looking at indexes of arrays or anything that's automatically numbered by the program, it will always start at 0. So the last character in our string object, when we run our program, we'll see that this has 12 characters in it. The last element will have the number 11, the index 11. Even though it has 12 characters, counting starts at 0. So it goes from 0 to 12. So this phrase 0 takes the entire phrase and looks at it as if it were an array, which we will talk about that later in the week. But it looks at the individual characters within the phrase, and then it counts them. 1, 2, 3, 4. We'll see that when we run our program. Okay, so we're looking at the position 0, and then we'll have our 2 new lines. Now we can also change characters in our string individually. So we're going to change the character at position 0. And in order to do that, we set phrase 0 in square brackets equal to L. And then we'll go ahead and output the phrase. Okay, now we're going to do a loop that will go through each character and tell each position and tell what character is at that position. So we have an unsigned int in our for loop, I equals 0, and we're going to run this as long as I is less than phrase.size, and at the end of each iteration we'll increment I. Each time the loop runs, we'll output character at position I is phrase with I in our square brackets. So this will run through all of the positions in our phrase, and it will keep running as long as our counter is less than the size of our string object. Each time the loop runs, it will print the position number that it's on and what character is in that position. Okay. Now, we're going to look at another member function of the string object. We can actually search the text within our string object. So we're going to say that the sequence over begins at location phrase dot find, and we want it to find the word over, and then it'll end the line. Okay, so this will look for the string over, the sequence over within our phrase, and then it will say where it finds over, what location that begins at. The next thing we want our program to do is look for something that's not in there. So we'll say if phrase.find eggplant is equal to string NPOS. This stands for no position. So if find eggplant returns string NPOS, no position, we will see out eggplant is not in the phrase. Okay, so that will return that string NPOS because we do not have eggplant in there. Find will either return the location where something begins as a position number, or it will return NPOS, that it doesn't exist. And that's a special constant that's defined in the string file, by the way. Okay? Now, another member function within our string object is erase. So we're going to erase whatever's at the 4th and the 5th position. The phrase is now phrase and L. Now we'll erase again whatever's in the 4th position. The phrase is now and if I say erase with an empty set of parentheses, that is a slightly different way to call erase, and that erases every character in phrase. So phrase becomes an empty string, which is equal to the double quotation marks. And we'll go ahead and print that so you can see what that does. Last part of our code, we're going to test whether or not phrase is empty. So if phrase is empty, and empty is a member function of the string object, if it is empty, we will see out that the phrase is no more. Okay, I think that's enough for this program. So we'll go ahead and return 0 to end our main function. Then close our main function, save, and now we'll go ahead and compile it. Line 26. Oh, I misspelled unsigned. Now, I run a.out, and it ran off the screen. Okay. So our phrase starts off as game over with 3 exclamation marks. Okay, that's printed by this line of code. Now we look at what the size is. The phrase has phrase size, 12 characters in it. The character of position 0 is G. That was using this code here. Phrase and then 0 in straight brackets. Then we changed the character of position 0 to an L, so the phrase is now lame over. After that, we have our for loop that iterates through each character in the phrase and then prints the position number and what character is at the position. So position 0 was an L, position 1 is an A, and so on all the way through. Okay, we wrote code to find out where the sequence over begins in our phrase, and it begins at location 5, which you can actually see that here. Position 5 is our O. Next we had a test, find eggplant, and if find eggplant is equal to the string in POS, then go ahead and print eggplant is not in the phrase. Okay, we erased positions 4 and 5, which changed us to lame instead of lame over. Then we erased 4, which gave us just lame. And then we erased the whole phrase, which gave us just an empty phrase. And phrase is no more because phrase empty returned true. Now, an explanation of how that erase function works. We told it to remove a 5-character string beginning at position 4. That is, and when I was writing this, I may have misspoken and said that it will erase position 4 and 5. What it actually does is it erases a 4-character or a 5-character substring beginning at position 4. So we erase beginning at position 4, 5 characters. Okay? So beginning at position 4, 4 is our space. If we count 5 characters, the space, the O is 2, V is 3, E is 4, R is 5. So there's our 5 characters. Erased out of it leaves us with just lame and our exclamation marks. The next time we issued the erase member function, we just put the 4. That tells it to remove all characters of the string starting at position 4. Okay, at this point, position 4 was now our first exclamation mark, so it erases from that point forward. So from 4 all the way on. The third time we left our parentheses empty, that erased every character in the string, leaving just an empty string, which we see here. Okay, so that is the string, the member functions and the data members of the string object. In our next segment, we'll look at arrays, which are another type of objects that are even more manipulable than this one is. So look for that particular video probably either tomorrow or the following day. Until then, have a great day, and let me know if you have any problems or questions.